This lesson we're going to talk about annuities. So the difference between annuities and formulas that we went over before. Annuity is when you're regularly putting more money. Interest formula is just one-time deposit and then just no more money going in, just watching that money grows with your interest. Annuity is going to be like example 1, you're going to put more money monthly, right? In this case, you're going to put $100 each month with the different interest rate. So obviously in this case, you're going to make more money because you're putting more money into the accounts in the regularly. And in that case, so once we realize if the problem is using annuity formulas or interest formulas, your annuity formula will be this. Right? So I'm going to show you how you're going to use that. If you read the example 1, basically this person wanted to put $100 deposit each month in 6% interest in 20 years, right? So you wanted to find out how much that person is going to make. That we're going to use the annuity formula because person is making the regular payments. So then if we plug into the formula, we will have A equals PMT is payment monthly, $100. And then you have 1 plus rate is 0.06 over monthly, so it will be 12 to the 12 times 20 years minus 1. Okay? And you need to have another parenthesis like that over your rate over your compounding period, which is 12, because monthly you're putting more money. If you're going to put all this in your calculator, and if you have a graphing calculator to be able to do all this in plug in at once, you need to make sure you put another parenthesis here. So another parenthesis right here to show this is going to be the numerator. So numerator, and another parenthesis right here to show this is denominator. So we can differentiate which is numerator versus denominator, right? Otherwise, you're not going to get the right number if you don't put this parenthesis on the numerator and denominator. So that's important. If you don't have a calculator where you can input all this number at once, you need to start from inside out. So probably you will do this, right? 0.06 divided by 12, and then you add 1, and then use the exponential key to do this 12 times 20, so it will be 240 exponents, and enter, and then subtract 1, and then you can multiply 100 from it, and that will be your numerator. Find your numerator value, and then do this denominator, 0.06 divided by 12, and divide the numerator value by that value. You should be able to get, I'm writing, so it will be close to 46,204.9. If you're having hard time finding this value using your calculator, because everyone have different calculator, I will not be able to go over how to use the calculator in class, but you are more than welcome to come visit me in my office hours, and then we can go over it together. The next problem, if we look at it, what they're asking is how much you need to deposit each month. So here, this problem is asking you to find this value, PMT. And the easy way to remember this is just rewriting this formula for PMT. So basically, let me see what you need to do. Isolate PMT here. You're going to multiply this by reciprocal of fractions. So if I show you on the example, if you have A equals to B times M over N, in order to isolate this B, you're going to multiply this by reciprocal, right? N over M. It means you're going to do exactly same thing on the other side. So that will cancel out. Now you will be solving for M, right? So for that same reason, in order to isolate this M, you're going to multiply by this on denominator and this on the numerator. So the formula you get for, let me write it, PMT, you get A times R over N over 1 plus R over N to the NT exponents minus 1 is what you're going to get, right? So if we know that's what we're going to do, it's easy to figure out how much you will need to deposit each month. You will have total amount, right? You have T, you have R. And this is going to be, each month will be N equals to 12 also. So then if we replace all that number into the formula I just showed you, that will be X, which is going to be PMT, equals to 200,000 times 0.08 over 12 all over 1 plus 0.08 over 12 to the 12 and 30 exponents minus 1. Right? Make sure you have a numerator versus denominator. And if you wanted to put all this into the calculator, you should end up getting close to 134 and 20. So deposit 134.20 each month in order to get 200,000 after 3 years with 8% interest, right? And I just wanted to give you a little value between so that you can check to make sure you are using your calculator fine. So the numerator, you should get 0.06667 when you round it. You don't want it to round too quick because that's not a final solution, right? 9.93573 is what you're going to get on denominator when you plug in all that number into the calculator. So next problem, example 3, is asking exactly same thing. How much do you need to deposit each month to meet your retirement goal? Retirement goal here is 200,000 also in 30 year. Only thing different between example 2 and 3 is your interest. So maybe you can stop this video and try this. And then match your solutions to see if you get this information. And if we replace, your X should be 200,000 times 0.082 divided by 12 all over 1 plus 0.082 over 12 to the 12 times 30 exponents minus 1. So you should get about 128 and 80. When you round it, it will be 84, right? So that's how much you need to deposit each month to make $200,000 with 8.2% interest after 30 years. So this example, you're going to end up using two formulas, right? So let's read the problem and what they're asking. It's Emily invests $250 a month for 5 years into accounts, earn 4% interest, compound monthly. So this information right here, it's $250 a month. So you're going to use annuity formulas, right, for the 5 years. But the next problem, it's after 5 years, she leave the money without making additional deposit into the account for another 25 years. How much will Emily have in the end, right? So after 5 years, for 25 years, she didn't put any more money in it. So whatever the money you got for this 5 years, after that, you're going to use the interest formulas. You cannot use annuity anymore because no more money going in, right? So that's what we need to figure it out. And I guess using this example, I wanted to show you when to use annuity and when to use the interest formula, right? So let's try that with finding out that first 5 years. Right, so first 5 years, you have 250 deposit with 1 plus 4% for every month for 5 years, right? And again, one more parenthesis if you're going to put whole thing at once, right? And then 0.04 over 12. And when you plug in this number, you will get close to 16,574 and 74 cents. So that's how much you get after 5 years. And then with that money, you wanted to live in accounts without making an account. So it's same account they're talking about. So it will be the same 4%, right? 4% and monthly. But even though you not deposit, it's going to be monthly because it's the same account. But because you're not putting monthly 250, you're going to use this compound interest formula. Your starting amount principal is going to be 16,574 and 74 cents. Compound interest is plus your rate over 12 months and 12 to rest of 25 years, right? And then this value should give you close to 44,979 and 95. So at the end of year, so a total of 30 years later, this is the amount that Emily will have.